Hello everyone. In previous class, we discussed about what is armature winding of the alternator and the classification of armature winding like single phase armature winding and polyphase armature winding. In this lecture, we will study about what is voltage regulation. Next, methods to find out the voltage regulation of the alternator or synchronous generator. The types of method to find out the voltage regulation is basically two types: direct loading method and indirect loading method. So we will discuss about these two methods. In indirect method, we will discuss about synchronous impedance, or it is also known as EMF method. Second is the Ampere-Turn, or also known as MMF method. Third is ZPF, means zero power factor, or Potier triangle method. And fourth is ASA method, means American Standard Association method. And finally, the reference of this presentation. So in this lecture, we covered all these topics one by one. So let's start with topic. Voltage regulation. So first question is that what is voltage regulation of the alternator? The voltage regulation of an alternator is defined as the change in its terminal voltage when full load is removed, keeping field excitation and speed constant. तो हम सिंपल लैंग्वेज में बोलें वोल्टेज रेगुलेशन क्या होता है? So no load minus full load divided by full load voltage. By using this formula, we can calculate the voltage regulation of the alternator. And voltage regulation is always calculated in percentage form. हमेशा हम जब भी वोल्टेज रेगुलेशन निकालेंगे वो परसेंटेज के फॉर्म में निकालेंगे. जैसे हम एफिशिएंसी को हमेशा परसेंटेज में कैलकुलेट करते हैं, सेम टू सेम हम वोल्टेज रेगुलेशन को भी परसेंटेज फॉर्म में निकालेंगे. The value of the regulation not only depends on the load current but also on the power factor of the load. For lagging and unity power factor condition, there is always drop in terminal voltage, hence the regulation value are always positive. While for leading capacitive load condition, the terminal voltage increase as load current increase, hence the regulation is negative in such case. The relationship between the load current and the terminal voltage is called load characteristics of the alternator. So you can see the diagram, and this is the load characteristics of the alternator, and this characteristics plot between the voltage and current. X axis पे हम load current को लेंगे और vertical axis पे या Y axis पे जो हम लेंगे voltage को लेंगे. तो ये जो characteristics है इसको हम बोलते हैं load characteristics of the alternator. इसमें जब हमारा लीडिंग लोड होता है तो हमारा वोल्टेज रेगुलेशन हमें नेगेटिव मिलता है, और जब लैगिंग लोड रहता है तो वोल्टेज रेगुलेशन हमें पॉजिटिव मिलता है. नेक्स्ट, डिटर्मिनेशन ऑफ वोल्टेज रेगुलेशन. अब हम वोल्टेज रेगुलेशन को निकालेंगे और कैलकुलेट कैसा करेंगे. अभी तो हमने समझ लिया वोल्टेज रेगुलेशन होता क्या है. So to calculating the voltage regulation, there is two methods. First, in the case of small machines, the regulation may be found by direct loading. In direct loading, the alternator is driven at synchronous speed and the terminal voltage is adjusted to its rated value V. The load is varied until the wattmeter and ammeter indicate the rated value of the desired power factor, then the entire load is thrown off, while the speed and the field excitation are kept constant. तो हम वोल्टेज रेगुलेशन दो तरीके से कैलकुलेट कर सकते हैं, एक तो डायरेक्ट लोडिंग के थ्रू और एक इनडायरेक्ट लोडिंग के थ्रू। तो जो स्मॉल मशीन्स हैं उसको हम डायरेक्ट लोडिंग के थ्रू कैलकुलेट करते हैं वोल्टेज रेगुलेशन, और जो लार्ज मशीन है उनको हम डायरेक्ट लोडिंग से कैलकुलेट नहीं कर सकते, सो वी कैन यूज इनडायरेक्ट लोडिंग मेथड्स। The open circuit or no load voltage E naught is read. So the percentage voltage regulation formula is that E naught minus of V divided by V, or we can say that E no load minus of V full load divided by V full load, means no load voltage minus full load voltage divided by full load voltage into 100%. So we calculate the percentage value of voltage regulation. So this is the formula. By using this to calculate the voltage regulation of the alternator, where V is equal to rated terminal voltage or full load voltage and E naught is called the no load voltage. Number 2, in case of large machine, the cost of finding the regulation by direct loading become prohibited. Hence, other indirect methods are used as discussed below. It will be found that all these methods differ chiefly in the way the no load voltage E naught is found in each cases. तो सारे केसेस में हम क्या करेंगे, नो लोड वोल्टेज और फुल लोड वोल्टेज को फाइंड आउट करेंगे. बाय यूजिंग दिस वी कैन कैलकुलेट द वोल्टेज रेगुलेशन ऑफ द अल्टरनेटर. So next topic is methods of determining voltage regulation of the alternator. The voltage regulation of an alternator can be determined by different methods. In case of small generator, it can be determined by direct loading, whereas in case of large generator, it cannot be determined by direct loading, but will be usually predetermined by different methods. The following are the different methods used for predetermining of regulation of alternators. Method to determine the voltage regulation of the alternator is broadly classified into two categories. First one is called the direct loading method and second is called the indirect लोडिंग मेथड. तो डायरेक्ट लोडिंग में हमारे पास कोई क्लासिफिकेशन नहीं होता है, बट इनडायरेक्ट लोडिंग मेथड्स आर क्लासिफाइड और कैटेगराइज्ड इनटू फोर कैटेगरी. फर्स्ट वन इज कॉल्ड द ईएमएफ मेथड और सिंक्रोनस इंपेडेंस मेथड. सेकंड इज एमएमएफ मेथड आल्सो नोन एज एम्पियर-टर्न मेथड. थर्ड इज एएसए मेथड और मॉडिफाइड एमएमएफ मेथड. ASA full form is American Standard Association method, and the fourth is ZPF method or Potier triangle method. So these are the type of indirect loading method to determine the voltage regulation of the alternator or synchronous generator. All the above methods other than the direct loading are valid for non-salient pole machines only. As the alternators are manufactured in large capacity, direct loading of the alternator is not employed for determination of regulation. Other methods can be employed for predetermination of regulation. Hence, the other methods of determination of regulation will be discussed in the following sections. So the first method is EMF method or synchronous impedance method. This method is also known as synchronous impedance method or EMF method. Here the magnetic circuit is assumed to be unsaturated. In this method, the MMF or fluxes produced by the rotor and stator are replaced by their equivalent EMF and hence called EMF method. The synchronous impedance method or EMF method is based on the concept of replacing the effect of armature reaction by an imaginary reactance. For calculating the regulation, the synchronous method requires the following data. They are the armature resistance per phase and the open circuit characteristics. तो जब अगर हमें कैलकुलेट करना है वोल्टेज रेगुलेशन बाय यूजिंग EMF मेथड, तो हमें फॉलोइंग डेटा जो है वो यूज होगा. पहला निकालना पड़ेगा, पहला आर्मेचर रेजिस्टेंस पर फेज, ओपन सर्किट कैरेक्टरिस्टिक्स एज वेल एज द शॉर्ट सर्किट कैरेक्टरिस्टिक्स ऑफ द अल्टरनेटर. The open circuit characteristics is the graph of circuit voltage and the field current. The method also required the short circuit characteristics, which is the graph of short circuits and the field current. For a synchronous generator, following are the equation given below. V is equal to EA minus of ZS into IA. या हमने नॉर्मल जो इक्वेशन पढ़ा था VT is equal to E minus IA into RA. R की जगह यहाँ पे हम ZS ले रहे हैं. Z is called the impedance and S is called the synchronous. So ZS is called the synchronous impedance. Z जो होता है वो हमारा कॉम्बिनेशन होता है R plus X मीन्स अंडर रूट ऑफ R स्क्वायर प्लस X स्क्वायर, वो होता है हमारा इम्पीडेंस Z. तो हमने R को ZS से रिप्लेस किया है. सो VT और V is equal to EA minus of ZS into IA, where ZS is equal to RA plus JXS. For calculating the synchronous impedance, ZS is measured and then the value of EA is calculated. From the value of EA and V, the voltage regulation is calculated. सबसे पहले हमें ZS की वैल्यू, चूंकि हमारी मेथड है सिंक्रोनस इम्पीडेंस, तो इसलिए हमें सबसे पहले सिंक्रोनस इम्पीडेंस को फाइंड आउट करना होगा. मींस ZS की वैल्यू हम कैलकुलेट करेंगे. आफ्टर दिस फाइंड आउट द वैल्यू ऑफ EA. V हमारे पास ऑलरेडी रहेगा. सो बाय यूजिंग दिस वी कैन कैलकुलेट द वोल्टेज रेगुलेशन ऑफ द अल्टरनेटर. Next is measurement of synchronous impedance. The measurement of synchronous impedance is done by the following methods. They are known as DC resistance test, open circuit test and short circuit test. इन तीनों टेस्ट का हम यूज करके we can calculate or find out the value of synchronous impedance ZS. Now first one is DC resistance test. So this is the circuit diagram for DC resistance test. In this test, it is assumed that the alternator is star connected with DC field winding open as shown in a circuit diagram. तो इसमें हम देख पा रहे हैं DC टेस्ट अगर हमें करना है तो इसमें हमारा जो आर्मेचर वाइंडिंग है वो स्टार में कनेक्टेड रहना चाहिए और फील्ड वाइंडिंग को हम ओपन रख देंगे. This is called the armature winding and this is called the field winding. It measures the DC resistance between each pair of terminals either by using ammeter or voltmeter method or by using the Wheatstone's bridge. The average of 3 sets of resistance value RT is taken. The value of RT is divided by 2 to obtain the value of DC resistance per phase. Since the effective AC resistance is larger than the DC resistance due to skin effect, therefore the effective AC resistance per phase is obtained by multiplying the DC resistance by the factor 1.20 to 1.75 depending on the size of the machine. A typical value of use in the calculation would be 1.25. Next is the open circuit test. So this is the circuit diagram for open circuit test. An open circuit test, for determine the synchronous impedance, the alternator is running at the rated synchronous speed and the load terminal are kept open. Means armature winding को हमें open रखना है और field winding को supply से connect करना है in case of open circuit test. Test का diagram आप देख सकते हैं figure में. This means that the load are disconnected and the field current is set to 0. The The circuit diagram is shown in a figure. After setting the field current to 0, the field current is gradually increased step by step. The terminal voltage ET is measured at each step. The excitation current may be increased to get 25% more than the rated voltage. A graph is drawn between the open circuit phase voltage EP is equal to ET by root 3 and the field current IF. The curve so obtained called as open circuit characteristics, in short OCC. The shape is same as normal magnetization curve. The linear portion of OCC is extended to form an air gap line. तो अब हम क्या करेंगे, ओपन सर्किट कैरेक्टरिस्टिक्स ड्रॉ करेंगे किस किस के बीच में, फेज वोल्टेज और करंट, फील्ड करंट के बीच में जो कैरेक्टरिस्टिक्स ड्रॉ होती है उसको ओपन सर्किट कैरेक्टरिस्टिक्स, इन शॉर्ट ओसीसी बोलते हैं. Next is a short circuit test. In a short circuit test, the armature terminal are shorted through 3 ammeter as shown in a figure. अब इसमें हम क्या करेंगे, जो हमारे पास आर्मेचर है 3 फेज का, आर्मेचर टर्मिनल को हमने एक वायर से शॉर्ट कर दिया और एम्पियर मीटर हम लगा देंगे टू मेजर दी शॉर्ट सर्किट करंट. आईएससी को मेजरमेंट करने के लिए हमने 3 एमीटर तीनों फेज में लगाए हैं. फील्ड वाइंडिंग जैसे कि तैसे हमारे जो डीसी सप्लाई से कनेक्टेड था, सर्किट सेम वैसे ही है. शॉर्ट सर्किट टेस्ट में सबसे इंपॉर्टेंट चीज है कि हम कभी भी रेटेड वोल्टेज नहीं अप्लाई करते. रेटेड वोल्टेज का 5 to 10% वोल्टेज ही हम अप्लाई करते हैं, क्योंकि हमारा आर्मेचर जो टर्मिनल है वो शॉर्ट है. अगर हम रेटेड वोल्टेज अप्लाई कर देंगे तो एक्स्ट्रा हाई करंट फ्लो हो जाएगा आर्मेचर वाइंडिंग्स में और वाइंडिंग्स बर्न आउट हो जाएगा. तो इसको प्रोटेक्ट करने के लिए शॉर्ट सर्किट टेस्ट में हम रेटेड वोल्टेज अप्लाई ना करके रेटेड वोल्टेज का 5 to 10% वोल्टेज ही अप्लाई करते हैं. The field current should first be decreased to 0 before starting the alternator. Each ammeter should have a range greater than the rated full load value. The alternator is then run at synchronous speed. Same as in open circuit test, that the field current is increased gradually in a step by a step and the armature current is measured at each step. The field current is increased to get armature current up to 150% of rated value. The value of field current IF and the average of 3 ammeter reading at each step is taken. The graph is plotted between the armature current IA and the field current IF. The characteristic so obtained is called as short circuit characteristic, in short SCC. This characteristic is a straight line as shown in a figure. So this is the short circuit characteristics of the alternator, जो कि हमें लीनियर कैरेक्टरिस्टिक्स मिलती है. दिस कैरेक्टरिस्टिक्स प्लॉट बिटवीन द फील्ड करंट एंड द आर्मेचर करंट. फील्ड करंट को हम एक्स एक्सिस पे कंसीडर करेंगे और आर्मेचर करंट को हम वाई एक्सिस या वर्टिकल एक्सिस पे नेक्स्ट इज द कैलकुलेशन ऑफ सिंक्रोनस इम्पीडेंस। अभी हमने देख लिया कि सिंक्रोनस इम्पीडेंस हम कैसे फाइंड आउट कर सकते हैं, तो बाय यूजिंग डीसी टेस्ट, ओपन सर्किट टेस्ट एंड शॉर्ट सर्किट टेस्ट। अब हम देखते हैं कैलकुलेशन कैसे करेंगे सिंक्रोनस इम्पीडेंस के लिए। The following steps are given below for calculation the synchronous impedance ZS. Number 1. The open circuit characteristics and the short circuit characteristics are drawn on the same curve. Number 2. Determine the value of short circuit current ISC and gives the rated alternator voltage per phase. The synchronous impedance ZS will then be equal to the open circuit voltage divided by the short circuit current at the field current, which gives the rated EMF per phase. So the formula of ZS is equal to open circuit voltage per phase divided by short circuit armature current for the same value of field current. So इस formula के through we can find out the synchronous impedance or calculate the value of ZS. The synchronous reactance is determined as XS is called the synchronous reactance is equal to under root of ZS square minus of RA square. The graph is shown in a figure. From the figure, consider the field current IF is equal to OA. This is called OA, this is called field current that produce the rated alternator voltage per phase. Corresponding to this, the field current, the open circuit voltage is AB. This is called the AB and this is called the value of a rated alternator voltage per phase. Therefore, ZS is equal to AB in volt divided by AC in ampere. Assumption in synchronous impedance methods. The following assumption made in synchronous impedance method are given below. Number 1. The synchronous impedance is constant. The synchronous impedance is determined from the open circuit characteristics and SCC. It is the ratio of open circuit voltage to the short circuit current. When the open circuit characteristics and short circuit characteristics are linear, the synchronous impedance ZS is constant. Number 2, the flux under test condition is the same as that under load condition. It is assumed that a given value of the field current always produces the same flux. This assumption introduces considerable error. When the armature is short circuit, the current in the armature lag the generated voltage by almost 90 degree. And hence the armature reaction is almost completely demagnetizing. The effect of armature reaction flux can be replaced by a voltage drop proportional to the armature current, and that the armature reaction voltage drop is added to the armature reactance voltage drop. The magnetic reluctance to the armature flux is constant regardless of power factor. For a cylindrical rotor machine, the assumption is subsequently true because of the uniform air gap. Regulation obtained by using a synchronous impedance method is higher than that obtained by actual loading. Hence, this method is also called the pessimistic method. all about the synchronous impedance or EMF method. The next is Ampere-Turn or MMF method. MMF method is also known as Ampere-Turn method. It's an indirect loading method. The synchronous impedance method is based on the concept of replacing the effect of armature reaction by an imaginary reactance, the magnetic motive force or MMF. The MMF method replaces the effect of armature leakage reactance by an equivalent additional armature reaction MMF, so that this MMF may be combined with the armature reaction MMF. So this is called the MMF method to calculate the voltage regulation of the alternator. To calculate the voltage regulation by MMF method, the following information is required. They are as follows. Number 1, the resistance of the stator winding per phase. Number 2, open circuit characteristics at synchronous speed. And number 3, शॉर्ट सर्किट कैरेक्टरिस्टिक्स. तो MMF मेथड में भी हमें ये तीनों चीजें फाइंड आउट करनी होंगी. रेजिस्टेंस ऑफ द स्टेटर वाइंडिंग पर फेज, ओपन सर्किट कैरेक्टरिस्टिक्स एज वेल एज द शॉर्ट सर्किट कैरेक्टरिस्टिक्स. तो जो भी इनडायरेक्ट मेथड हैं, जो कि 4 टाइप की होती हैं, सारी मेथड्स में हमें OCC और SCC जो है वो ड्रॉ करनी पड़ेगी और उसी के थ्रू हम वैल्यू निकालेंगे नो लोड एज वेल एज द फुल लोड वोल्टेज की. Or by using this we can calculate the value of voltage regulation of the alternator. So next is steps to draw phasor diagram of MMF method. Open circuit, short circuit characteristics already हमने previous वाली slides में देख लिया है कैसे हम draw करेंगे. तो इसमें हम डायरेक्ट phasor diagram पे concentrate करते हैं. So the phasor diagram at lagging power factor is so in figure. This is the phasor diagram for lagging power factor. The armature terminal voltage per phase V is taken as the reference phase along OA. सबसे पहले क्या किया है हमने, OA जो लाइन है उसको as a reference लिया हुआ है. So this is O and this is the A. OA is called the reference voltage V. The armature current IA is drawn lagging the phase voltage for lagging power factor angle phi. अब हम क्या करेंगे, हमें जो करंट ड्रॉ करनी है वो हमने करंट यहाँ पे ड्रॉ करी है IA. This is called the IA current. सबसे पहले क्या करना है हमें OV या सॉरी OA लाइन हम बना लेंगे जिसको हम रेफरेंस वोल्टेज भी मानेंगे. इससे फाई एंगल पे हम एक करंट ड्रॉ करेंगे बिकॉज हमारा लैगिंग पावर फैक्टर है IA करंट हमने ड्रॉ कर दी, फॉर विच द रेगुलेशन इज कैलकुलेटेड. The armature resistance drop phasor IA into RA is drawn in phase of IA along the line AC. अब क्या करेंगे हम, अब हम जो IA into RA लॉसेस को ड्रॉ करना है जो कि वोल्टेज पे ड्रॉ होते हैं, और IA into RA लॉसेस जो होते हैं वो सेम फेज में होते हैं करंट के. तो ये करंट अगर मेरा ऐसा जा रहा है तो इसी के पैरेलल हमने एक IA into RA लॉसेस बनाए जिसको हमने AC से रिप्रेजेंट किया हुआ है. ज्वाइन O एंड C. अब हमने क्या किया है, एक टर्मिनल हमें यहाँ पे C मिल गया, C को हमने O से मिला दिया. सो वी गेट द रिप्रेजेंट और वी गेट द EMF E. तो जब हम इनको मिला देंगे तो इस बार ये वाला वेक्टर जो है वो हमें E दे देगा. Considering the open circuit characteristics so above, the field current IF corresponding to the voltage E is calculated. तो ये जो E है हमारे पास, E की वैल्यू मिली है, E के करस्पॉन्डिंग हम ओपन सर्किट वोल्टेज पे लाइन खींचेंगे, ओपन सर्किट वोल्टेज पे जो है वो हम IF या फील्ड करंट जो है वो फाइंड आउट कर लेंगे। Draw the field current IF leading the voltage E by 90 degree. It is assumed that on short circuits all the excitation is opposed by MMF or armature reaction. Thus, IF dash is equal to IF dash angle 90 minus of alpha. From the short circuit current characteristics shown above, determine the field current IF2 required to calculate the rated current on short circuit. This is the field current required to overcome the synchronous reactance drop, means IA into XA drop. So number 1, draw the field current IF2 in phase in opposition to the current armature current IA. Thus, IF2 is equal to IF2 angle 180 degree minus of phi. ये फेजर डायग्राम में हम ड्रॉ करेंगे। Next is zero power factor और Potier triangle method. इसको हम नेक्स्ट वाले लेक्चर में डिस्कस करेंगे। इसके साथ हम डिस्कस करेंगे ASA methods. Full form is American Standard Association Method to determine the voltage regulation of the alternator. ये दोनों मेथड हम नेक्स्ट वाले लेक्चर में देखेंगे। Next topic is reference. And thank you for watching this video.